Okay, so in this video, we will consider an example of a random variable, construct its probability distribution table, its histogram, find its mean, its variance, and its standard deviation. So here's the experiment. Consider that we have an urn that contains 3 blue balls and 5 red balls. And the experiment is we will choose from this urn randomly 3 balls. And, well, what is our random variable? Let's say here that x, our random variable, is the number of blue balls selected. So x is obviously here a random variable. Why? Well, if you choose 3 balls from this urn randomly, the number of blue balls that you have will vary, right? Sometimes you may get 0 blue balls, sometimes you may get 1, other times 2, other times 3. And each time you have a number, the number of blue balls selected. So here x is a discrete random variable. The first thing we construct, or at least let's state what are the possible values for the random variable. Since we are choosing 3 balls at random and there are 3 blue balls, well, x could be 0, so maybe none of our balls are blue, maybe exactly 1, or exactly 2, or exactly 3. So there are 4 possible values here for our random variable. And always remember, use uppercase X for the random variable, use lowercase x for the actual values that the random variable can take. And all we need now is to build what's called the probability distribution of x. And once we have this, everything will be done very easily from this distribution table. And what a probability distribution is simply an assignment of probabilities. So the probability distribution of x. Well, we will assign to each value of x its corresponding probability. And of course, lowercase x contains the actual values that the variable can take. So x can be 0, or it can be 1, or it can be 2, or it can be 3. And to each possible value that x can take, we assign its probability. So what is the probability that the random variable equals the corresponding x value? So for each value, let's find the corresponding probability. Let's do it here on the side. So first, probability that x equals 0. Well, x is the number of blue balls, and we're asking, if we choose 3 balls at random, what is the probability that the number of blue balls is 0? Well, here, look at the experiment. The setup that we have is without replacement. Once we pick a ball from the urn, we don't put it back when we pick the second, so it is without replacement, and we do not care about the order of the selection. All we are interested in is, out of the 3 balls selected, how many are blue, how many are red. So we have a setup that is without replacement and unordered. That is the setup of combination. And because each selection is equally likely, we can use the equiprobability theorem. So, in how many ways can we choose 0 blue balls? Well, out of the 3 blue balls, we choose none, and times, because we are choosing 3 balls in total, out of the 5 red balls, we choose 3, over the total number of possible selections, the size of the sample space. Well, out of 8 balls, 3 plus 5 is 8. Out of 8 balls, we are choosing 3. And if you compute the numerator and the denominator, what you have is 10 out of 56. And now there you have it, the probability that x equals 0, hence that the number of blue balls is equal to 0 is 10 out of 56. And if you compute the decimal for this, you will get approximately 0.179. Let's keep going. The probability now that x is equal to 1, so the number of blue balls is equal to 1. Well, this means out of the 3 blue balls we choose 1, and therefore out of the 5 red we choose 2, over again the total number of possible selections, 8 choose 3. And if you compute this, you'll get 30 out of 56. If you compute this approximately, you'll have 0.536. Let's keep going. What is the probability that x equals 2? That the number of blue balls selected is equal to 2. Out of the 3 blue balls, we choose 2. Hence, out of the 5 red, we choose 1, over the total number of possibilities, 8 choose 3. The exact fraction is 15 out of 56. And if you find the decimal expansion, you'll get approximately 0.268. And finally, what is the probability that x equals 3? So the number of blue balls is equal to 3. Well, out of the 3 blue balls, we choose 3. And out of the 5 red, we choose none, over the total number of possibilities, 8 choose 3. And this gives us 1 out of 56. And that's approximately 0.0179. And now we have the probability distribution of x. For each of its possible value, we have the corresponding probability. And if you notice, if you add all these up, you get 10 plus 30, 40, plus 15, 55, 55, sorry, plus 1, 56. 56 out of 56. So the total is equal to 1. So when you build your probability distribution, since you will consider all possible values of x, when you add the probability of each case, it has to add up to 1 because you're adding over all possibilities. If it doesn't happen to add up to 1, you've made a mistake somewhere, so double check your work. And now we have the probability distribution of x. From this, we can easily find the mean, the variance, and standard deviation. Let's find the mean first. So the mean is the expectation of x. And if you remember, all we have to do is sum over all possible values of x, the value times the probability that the random variable equals this given value. Well, the first term is x equals 0, so it's 0, times its corresponding probability, 10 out of 56, plus, when x is 1, 1, times its probability, 30 out of 56, plus, when x is 2, 2 times its probability, 15 out of 56, plus, finally, the third value, 3 times its probability, 1 out of 56. And here when you compute this, use the fraction command on your calculator to get the exact value as a fraction. And if you do, you will get that the mean is equal to 63 out of 56, right? 0 plus 30 plus 30 is 60, plus 3 is 63. Whoops, sorry. It's not 1 out of 15, it's 1 out of 56, right? 3 times 1 over 56, 3 times 1 over 56. If you add those up exactly again, you will find that the mean, the average value of our random variable, is 63 out of 56. And if you find the decimal expansion, it happens to be exactly 1.125. But keep mu as a fraction for now. So think of what this is saying. Mu is the mean, the expectation, the average value of x. So if you say, out of this urn, where there are 3 blue balls and 5 red balls, if I choose 3 balls at random, and x is the number of blue balls, what do I expect x to be equal to? Well, you should expect x to be equal to 1.125, but x is the number of blue balls, so you would round off to 1. So on average, as you pick from this urn 3 balls, on average, approximately 1 ball will be blue and the other 2 will be red. Let's now look at how much variability there is in this random variable. And this is done, of course, by computing the so-called variance. And we denote this by sigma squared, or v of x. And this is, if you remember, the sum over all x values, the difference between x and the mean squared, times the probability of observing this particular x value. So let's go. And again, we'll find the exact value of the variance. So we look up and we say, well, what's the first value? It is 0. So 0 minus the mean squared. So 0 minus the mean, 63 out of 56, all squared. So that's this term, times the probability of observing an x value of 0. Well, the probability of this was 10 out of 56. So times 10 over 56. Let's keep going. Plus the next x value when x is 1. So 1 minus the mean squared. So 1 minus 63 out of 56 squared times the probability that x equals 1. Well, this is 30 out of 56. Plus the other value of x when x is 2, so 2 minus the mean squared, times the probability of observing x equals 2, and that is 15 out of 56. Plus our last value of x when x is 3, so 3 minus the mean, 63, out of 56, squared, times the probability of observing a value of x equals 3, and that is 1 out of 56. And there you have it, right? So you sum over all possible values of x, x minus the mean squared, 1 minus the mean squared, 2 minus the mean squared, 3 minus the mean squared, and you have to multiply each term by the probability of observing the particular x value. 0 was a probability of 10 out of 56, 1, 30 out of 56, 2 was 15 out of 56, and 3 was 1 out of 56. When you compute this again, use the fraction command on your calculator to get the exact value, and you should find a value of 225 divided by 448. And that is the variance of the random variable. If you want an approximate value to get a feeling for what the value is equal to in decimals, you can compute, and you'll get approximately 0.502. And finally, the easiest quantity to compute is the standard deviation. It is simply the root of the variance. The variance is 225 over 448. And if you compute this, you get approximately 0.709. And you have your standard deviation. So you see, it's very easy to find the mean, variance, and deviation once you build your probability distribution table, which is an assignment of probability to each possible value that your random variable can take. Finally, we'd like to graphically visualize this distribution table by building the histogram for x. And all we do is we plot the probabilities along the y-axis over the values of x along the x-axis. And now we have our histogram for x. Let's do this. As we've just said, the y-axis contains the probabilities. So this will be the probability that the random variable equals the given particular x value over all possible x values. Well, we only had, if you remember, 4 possible values of x. X was allowed to be 0, 1, 2, and 3. So x equals 0, x equals 1, x equals 2, x equals 3. And now along our y-axis, where we'll include the probabilities for each possible value of x, we don't have to go up to 100%. Simply go up to about the largest probability. So roughly 0.18, 0.53, 0.27, 0.018. So we'll go up to, let's say, 0.6, 60%. So we can go in slices of 10%. So we'll go with 1, 2, 3, 4, 5, and 6. And beside each, write the probability. So 0.1, 0.2, 0.3, 0.4, 0.5, and finally 0.6. And now, all we have to do is, above each value of x, include a vertical bar whose height corresponds to the probability. So here it's roughly 0.18. That's a little below 0.2. And put the bar right in the middle of the given x value. So you see the probability of x being equal to 0 is approximately, from our histogram, 18%. What about x equals 1? It's about 0.54%. So it's about in the middle of 0.5 and 0.6. And once again, the height of the vertical bar about x equals 1 represents the probability that x indeed is equal to 1. What about 2 now? The probability is about 0.27. That's slightly below 0.3, about here. And finally, when x equals 3, the probability is about 2%. So it's going to be really low, about this. And now let's see, with respect to the histogram of x, let me write this here. This is the histogram of x. Let's see how the mean and the variance fit in with this picture. If you remember, the mean was exactly 63 out of 56. We'll use here the decimal, 1.125. The variance was exactly 225 over 448, which is about 0.502. And the deviation was roughly 0.709. So if you look at the mean, about 1.125, and you see it's about here. And the mean is, again, the average value of the random variable. So you can look at the histogram and say, the average is about a little bigger than 1, and here it's 1.125. And the deviation gives you how much variability there is from the mean. And you see the deviation here is not too big, so most values are about the mean. If sigma was much bigger, you'd have higher bars away from the mean. If sigma was even smaller, you'd have even higher bars about the mean value. And this completes our example. And once again, if you remember, the mean is just your average value. What do you expect x to be equal to? So if we were to pick 3 balls from our urn, we would expect to get 1 blue ball and 2 red balls.